So we're in Tech Math 2. We're going to do section 4-4 today. And yeah, we did 4-3 yesterday, didn't we? Yeah, we did 4-3 yesterday. So in 4-4 we have two things. If I have two lines that are parallel, so I have L1, L2, and L1 is parallel to L2, then the slope of the first line has to equal the slope of the second line. Now, is that always true, that parallel lines don't cross, right? Because their slopes are the same. Is that always true? No, it's not. So in spherical geometry, parallel lines are going to cross twice. Yeah. So in spherical geometry, which of course we're not doing, the lines that go through the poles that circle the Earth, they cross twice. So that's a weird thing, but other than that, you know, we have all kinds of weird things in math, so we just put up with it. The other thing that we have is that if I have line 1 and line 2, so I have line 1 and line 2, and they are orthogonal to each other, O-R-T-H-A-L. Oh, that's misspelled. So we'll just say they're perpendicular. That's probably misspelled too. Anyway, they're at a 90-degree angle. If that's the case, then the slope of the first line is going to be -1 over the slope of the second line. And so it's an inverted with a negative sign in front of it. Okay, so those are the two rules that we're following today that we didn't have yesterday. And now we're going to look at problem number 1. And problem number 1 says, determine whether each of the pair of equations represent lines that are parallel, perpendicular, or neither. Okay, so problem number 1 we have x plus 3y is equal to 7. And minus 3x plus y is equal to -2. All right, now in that particular form, we don't know much, so we're going to put in the form y is equal to mx plus b, and then we're going to know what the slope is, because that's what we're looking for. Okay, so our first equation, we're going to say y is equal to -1/3 x plus 3 goes into 7/3. All right. And then the second equation, we really don't care what the y-intercept is. We only care what the slope is. Y is equal to 3x minus 2. Well, you see that the slope -1 over 3 is equal to -1 over 3, right? So the slope of the first one is equal to -1 over the slope of the second one. So these guys are perpendicular lines. Now I know that there are several things in your makeup that are not correct, right, that I'm trying to correct. And one of those is that while I'm doing a math problem, you only want to use one line. Okay? Whereas when I do a math problem, I like to use the whole paper. So I'm trying to correct that in your fundamental upbringing to allow you to see past the one-line answer and to use the whole sheet of paper answer so that you can get the correct response. In the past, you're perfectly happy going one line, getting the wrong answer, and moving on, right? Yeah. So we're trying to correct that problem. If we are, number 2. X plus 2y is equal to 11. X plus 2y is equal to minus 4. Alright, so we're going to put them in the y is equal to mx plus b, so y is equal to minus 1/2 x plus 11 over 2. And the second guy, y is equal to minus 1/2 x minus 2. And we see that the slopes are equal. Because the slopes are equal, slope 1 is equal to slope 2. That implies L1 parallel to L2. Okay, we'll look at number 6. Minus 3x plus 9y, 22, no it's not, minus 22, and x plus 3y equals 17. Okay, well, take the first guy, say that y is equal to, okay, we're going to throw that on the other side and divide by 9. 1/3 minus 22 over 9. And then we'll take the second guy, y is equal to 1/3 x plus 17 over 3. The slopes are equal, therefore line 1 is parallel to line 2. All right, well, number 8. Find the equation of the line that satisfies these conditions. Okay. It passes through point 2 minus 2, and it's perpendicular to 3x minus 2y is equal to 14. All right, so what we need to do is find the slope of the line it's perpendicular to, and then find the slope of the line we're looking for, and then find the equation of the line we're looking for. So that's going to be my plan. So I take this guy, y is equal to 3 over 2x. So that goes to the other side of the equation. It becomes minus 3x. I divide by minus 2, and the 2 minus signs go away, is equal to my plus minus 7. Minus plus minus 7. Okay, so the original guy is that. So 3 over 2 has to equal 1 over, minus 1 over the slope of the second guy. All right, so the slope of the second guy, minus 1 over 3 over 2, invert and multiply, minus 2 over 3. Okay, so now I'm going to use the point slope form, y minus 2 is equal to minus 2 over 3x times x minus, what is x1? 2. All right, so I've got y plus 4 is equal to minus 2 over 3x plus 4/3. I'm going to multiply everything by 3. 3y plus 12 minus 2x plus 4. 2x plus 3y is equal to minus 8. Okay, we call this the general form of a line. So in the form ax plus by is equal to c. That's the general form of a line. We could have written that in a point-intercept way. So we could have said y. We could have wrote it in slope-intercept. So we could have said y is equal to minus 3, minus 2, minus 2 over 3x, minus 2 over 3x minus 8 over 3. And that would be the same equation. We could write it either way, and unless it told us to write it one way or the other, that's what we would do. Okay, number 15. Has a y-intercept at 8. B is 8. And it's parallel to y, so I'm parallel to y equals 2. All right, so I come over here, there's y equals 2, it sits there, and it's got a y-intercept up here at 8, so I would say y is equal to 8, final answer. Yeah, that was pathetically easy. Was that pathetically easy? It wasn't? Once you figure out where y is equal to 2 is, so there's 2, and it's got to go through 8 because that's the y. So y is equal to mx plus the y-intercept, right? And what's the slope of the line y is equal to 2? The slope is 0, so it has to have the same slope. So y is equal to 0x plus 8. Y is equal to 8. There, that not skip any steps. That better? Just a little bit? Okay. All right. Guess we'll do 19, and then we'll do, no, we won't. We'll do 20. All right, so, but before we do 20, we're going to go and see if I can find some graph paper. Graphing, there we go. All right, so there's some graph paper. There's an XY guy. That looks good. Think the XY guy is all right? Yeah, there we go. So I got some graph paper. I'm doing number 20. See how easy that is? Just pop graph paper up, you know. You don't have to steal it from your little brother or anything. So I've got A at minus 4, 1. 1, 2, 3, 4, 1. Okay, so there's A. And then I've got B at 0, minus 2. 0, minus 2. That's where B is. And then I got C at 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6, C. And then I've got D at 2, 9. 2, 6, 7, 8, 9. All right, so those are the points I have. I'm going to go and go way out on the limb here, and I'm going to go in and hook up straight lines instead of doing my normal. See how curvy I can make the line guy be. Okay, so that's what we have, and the issue is this a quadrilateral? Oh, is this a pentagon? And is it a quadrilateral? Is it a rectangle? All right. Oh, is the quadrilateral a pentagon? Okay, I got it. So is it a parallelogram? All right, so we're going to go and look at A to B. Is A to B parallel to line CD? That's the question we're going to ask. And is the line AD parallel to the line BC? Okay, so those are, if that's true, if they're both parallel, then I have a parallelogram. If they're not, then I don't. Okay, so that being the case, we're looking at the slope of A to B. Okay, that's going to be the change in y, 1, 2, 3, minus 3, divided by the change of x, 1, 2, 3, 4. And then we're going to look at the slope of CD. Slope of CD, that's going to be change in y, 1, 2, 3, change in x, 1, 2, 3, 4. So that's going to be minus 3 over 4. So this is true. I am parallel. Okay, now I'm going to look at the slope A to D. And change in y. D is up there. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 8 over 6. Also known as 4 over 3. And then I'm going to look at the slope of BC. And so BC, I got change of y, 1, 2, 3, 4, 5, 6, 7, 7, 1, 2, 3, 4, 5, 6, 7, 8. That's better. 1, 2, 3, 4, 5, 6. 8 over 6. There you are, equal, so this is true. So I know, therefore, I have a parallelogram. P A R A L L E L O G R A M. Okay, got that. So now the issue is, do I or do I not have a right angle? There, and there, and there, and there. And we only have to check one of them because these guys are parallel. So as soon as one of them checks to be a right angle, they all have to be right angles. We don't have a choice. Okay. So all I'm going to do is just, I'm going to check, is AB perpendicular to BC? Okay, so is AB perpendicular to BC? That's the question before the house. All right, so is the slope of AB, which is minus 3 divided by 4, is that equal to 1 over, minus 1 over the slope of BC, which is 8 over 6? Okay, so that's the issue, is that equation true? So I've got minus 3 over 4 equal, I'm going to invert and multiply, 6 over 8 with a minus sign. I'm going to divide top and bottom by 2, minus 3 over 4. True. Therefore, I have a rectangle. Okay. Good enough? All right. So we will do a Control Alt F12.